Hi class, here we are, 5.2, Verifying Trigonometric Identities. Now I want you to take a second and read through this sheet on 5.2 before I touch on some of the highlights. So go ahead and hit pause and read through 5.2 in those paragraphs on the introductory page. Okay, a couple things you should know before verifying identities. What I want you to realize is that when you're verifying something, it's a proof. And so the process is very important that you do as I ask you to. You will be counted off if you don't show your work and if you don't follow this process. When verifying an identity, you cannot assume that the two sides of the equation are equal because you are verifying they are equal. So that means that you can't work both sides of the equation. You can't add the same quantity to both sides and you can't cross multiply. So the rules are you can only manipulate one side of the equation. You must show all steps because it's a proof, and you must work down your paper, not left to right. There are no steps to help guide you through these problems, as each identity requires a different set of skills. All of those skills that you guys have practiced in chapter 5.1 or in section 5.1. So if you keep following the guidelines and keep them in mind all the time, and if you practice, this will get a lot easier. You guys need to be ready for it maybe to be a little bit frustrating at the beginning. However, it does get better. Guidelines. Begin on the more complicated side of the equation, though you don't have to. This is just what has helped most people. Use your toolbox, look for opportunities to factor, add fractions, square a binomial, create a monomial denominator, or multiply by a well-chosen one. Always look for identities. Keep the goal in mind. If all else fails, you can convert to sines and cosines. However, this is not efficient, and it will not be the best way to take a test or to get through this chapter. Please don't erase your work. This is actually one of my favorite rules. If you get stuck, go back to the last line that you were confident was correct and make a different decision. Cross out the work where you went astray. You guys, you're going to learn a little bit of humility here because I guarantee you, you will not always make the right decision. Finally, maintain a positive attitude. Try and think of this as a really fun puzzle. You're learning how to troubleshoot, which is something that we all must learn throughout problem solving, and it will help you in other classes and in future years. So let's get started. Verify the identity. Over on the left, I see secant squared theta minus 1 over secant squared, and it equals sine squared. I am going to choose the left side because it looks more complicated. When I look at the top, I see something squared along with a 1, and so I hope you're thinking it too, Pythagorean identity. I know that secant squared theta minus 1 is equal to tangent squared theta. Divided by secant squared theta. So whenever you make your first step, you should change one thing and then keep the rest of it the same. So I changed the top line to tangent squared theta and the bottom line to secant squared. Now in this case, I can jot down to the side, or I'm just thinking, I'm going to use my reciprocal or quotient identities. So these are very basic identities over here. So tangent I know to be sine squared over cosine squared divided by secant squared, which is 1 over cosine squared. You have to show this line. It's really important. Now, the next one is up for a little bit of discussion. I know that these cosine squareds are going to go away, and I think that you don't necessarily have to write this line if you know that also. However, I need to show my work for those of you that don't see this as blatantly as I do. Sine squared divided by cosine squared. Dividing by fractions is easy as pie. You flip the second fraction and multiply. So now I see sine squared over 1, which is sine squared, which is what we were trying to get. Now, if you want to, you can write sine squared every single time, just to help you maintain a goal and keep it in mind. Oh, you get to put the check mark because it makes you feel better. 2 times secant squared alpha equals 1 over 1 minus sine of alpha plus 1 over 1 plus sine of alpha. This time I am going to start on the right side. Seems seriously more complicated. You practice this skill in 5.1c. You're adding fractions with a different denominator, so you need a common denominator. So I'm going to multiply this side times 1 plus sine of x, and if I do it to the bottom, I have to do that to the top so that it stays, I'm multiplying by 1. Over here, I'm multiplying by 1 minus sine of x on the top and on the bottom. All right, top to bottom, left to right, here we go. 1 plus sine times 1 is 1 plus sine of x. 1 times 1 minus sine. Careful with this sign right here. If it's a negative, that really trips some people up because you'd have to distribute a negative value to both of these. In this case, they're both positive. So I have plus 1 times 1, and I have plus 1 times negative sine. My denominator, 1 plus sine times 1 minus sine. This time I'm thinking I am going to go ahead and FOIL because anticipating ahead, I see these signs are going to go away. Simplify. You're left with 2 over, change this using a Pythagorean identity. Hope you feel very comfortable with them by now. 1 minus sine squared is cosine squared. And 2 over cosine squared x would be 2 times 1 over cosine squared x. And these should be alphas, but I wrote x the whole time. It's okay. I'm going to go back to alpha now. 2 times secant squared alpha. This was a basic identity. Good job. Okay, I'm going to let you take the opportunity to try both of these on your own. You might get stuck, but go ahead and try them so that you can get started. Go ahead and hit pause and try each of them. Okay, part C. I am starting on the left side because I think it is much more complicated. I am going to FOIL these out. Tangent squared times cosine squared. My outside terms would be minus tangent squared. My inside terms would be plus cosine squared. And lastly, I'd have a minus 1. I'm thinking that something interesting has to come out of this. So I'm going to write it as sine squared over cosine squared times cosine squared. Again, it's important that you rewrite the rest of it every single time. Each line has to be equivalent to the previous line. So if I had not written this here, it would be wrong because it's not equivalent to the line before. I see that cosine squared divided by cosine squared is 1. So now I have something with a sine squared, a tangent squared, a cosine squared, and a negative 1. So how can I make this work for me? Looking at squared things and ones, there's a variety of things I can do. I could do cosine squared minus 1. What does that equal? Sine squared. In that case, I would change this to a sine squared. I'd have 2 of those, 2 sine squared minus tangent squared, which I'm wondering if it could be a little simpler. Notice my thought process. My thought process here is that I need to explore all my options, and so often in math we just want to write down and keep writing, but it's really good to analyze and look at the problem in front of you. I think there might be a better option than changing that to sine squared. Instead, what I think I'll do is I'll take this sine squared and this cosine squared and change that to 1. So if it's not obvious to you, I'm going to go ahead and write it in order. Sine squared x plus cosine squared x minus tangent squared x minus 1. I put these together to show you that this is really 1 minus tangent squared minus 1. The 1 and the negative 1 will simplify, and there you're left with negative tangent squared x, which is what you started with. It's important to think about a decision before you make it and see if it's getting you closer to what you had in mind. Tangent plus cotangent. When I see this problem, I like to change to sines and cosines. I don't know what else to do other than change to sines and cosines. So here we go. Sine of x over cosine of x plus cosine over sine. Excellent. Adding fractions need a common denominator. On the top to bottom, left to right, sine squared x plus cosine squared x, all divided by sine times cosine. Now, it's important to look back at what we want. We're wanting a secant and a cosecant, which I'm really happy that I have a sine and cosine on the bottom. Up here at the top, it would be a lot more helpful if that could change to a 1. Lucky for us, we have Pythagorean identities. So changing sine squared plus cosine squared to 1 over sine of x times cosine of x, it's really important that you show this line. 1 over sine is cosecant times 1 over cosine, which is secant. And if you really want to get down to the nitty-gritty, you would put secant of x times cosine of x. You'd apply the commutative property of multiplication. And I made a little tiny writing error. I don't think I said it. But secant times cosecant. Very good. I think we have 3 more. Okay, I want to be honest with you and tell you that the first time that I did problem E, I ran into a problem and I had to start it over. And so even after all these years of experience, I'm not exactly sure what the best decision is getting started each time. So I want you guys to have some patience while you're learning and let yourself learn. Let me show you what I did that took me down the wrong path. I took cotangent squared theta. I thought that the left side seemed more complicated because it had multiple trig functions and something squared. The first thing I did was I multiplied by a well-chosen 1. I tried to multiply by the conjugate. And it really seemed promising at first. I'm not going to distribute on top. I don't think that would be a good decision yet. On the bottom, I get foiling this out. The reason why I decided to FOIL out is because I know that cosecants and cotangents have a Pythagorean relationship. So I went ahead and wrote 1 minus cosecant squared theta. Once I had that, I thought, what could I change this to? What does 1 minus cosecant squared actually equal? Well, it does have a Pythagorean identity. Cotangent squared theta times 1 minus cosecant theta. The Pythagorean identity is that you can manipulate the equation so that 1 minus cosecant squared actually turns out to be negative cotangent squared. And this is where, oh, I thought I was running into a problem, but it's not that bad. Okay, it actually works. Cotangent squared over cotangent squared is 1. Do not forget about this negative sign. Right now, you're left with negative 1 plus cosecant of theta. I think when I originally did the problem, I forgot about the negative 1. So negative 1 plus, remember what we're working towards, something with signs, 1 minus sine over sine. So 1 over sine of theta. Right now I have 2 terms and I would like to get a common denominator of sine. So this actually isn't looking too bad. So this is really over 1. Multiply it by sine of theta and sine of theta. Right now I have negative sine of theta plus 1 over sine of theta. And if I believe I remember this correctly, all I'd have to do is use the commutative property to write this as 1 minus sine of theta over sine of theta. Next problem. I put a star by this one because I want you to recall that sometimes that conjugate can be your best friend. So let's multiply this by the conjugate of 1 plus sine. Oops. You know what? I'm going to rewrite the whole thing. This is cosine of x over 1 minus sine times conjugate would be 1 plus sine. And I should probably put some parentheses in here. Keep it organized. 1 plus sine on the top. So we just multiplied by a well-chosen 1. I am not going to distribute yet on the top. Cosine of x times 1 plus sine of x, all divided by 1 minus sine squared. Foiling that out. Looking at this, I see an excellent Pythagorean identity. The reason why I'm happy is because of the cosine on top. So cosine of x times 1 plus sine of x, all divided by cosine squared. Sorry guys, I must have some allergies. I keep pausing so that I can cough and not cough in your ear. 1 cosine over cosine squared, I can take off one of these and get rid of this one. Right now, I have remaining 1 over cosine plus sine over cosine. I split the fraction. I had 1 plus sine over cosine, and I took this 1 and put it over cosine and took this sine. So you guys are used to taking fractions and going this way, but in this case, we split fractions. Looking at what I'm trying to reach, I'm wanting secant plus tangent. It's a good thing that I have arrived where I have. This is secant x plus tangent x. And you did a great job there learning how to use multiplying by a well-chosen 1, in this case a conjugate. I thought that the right side was much more complicated because of the fraction. Last problem. Look at all those squares and fourths. Lots of stuff. I really hope you agree with me that it's the right side that's more complicated. I'm looking at two terms here, and I see this tangent squared glaring at me. So I think I am going to find the GCF. Factor out this tangent squared x from both sides. And this can actually be a pretty simple proof if you let it. Here's where I remind you to always keep looking at what you want. It's really good that this tangent squared x is here. What I'm missing is another tangent squared x. In this case, looking at this identity, it helps if you have memorized that when it comes to Pythagorean identities, secants and tangents go together. So in this case, secant squared x minus 1 is equivalent to tangent squared, and I am glad that we ended on an easy problem. I hope you have a very nice day. Go math. Hurrah or hooray for Flip This Classroom. And I'll see you tomorrow. Have a good night.